Hi friends, in this video we are going to solve one more problem. So here evaluate the double integration of this function xy by under root 1 minus y square dx dy over the first quadrant of the circle. So here we have the circle of centered origin of radius 1. So here, but in the question, region of my integration is the first quadrant of my circle centered at origin with radius 1. So here this is the first quadrant of my xy plane and the region of my integration is, let's say, OAB. So this is the region of my integration. I want to find the total accumulation, of my this function over this region. So here either you can use vertical strip method or horizontal strip method. So here I want to use this vertical strip method. Let's say here first I will draw the vertical strip AB which is parallel to y axis. Let's say this is the vertical strip C and D. So let's say this is my vertical strip CD. Start on x axis and terminate on the circumference of the circle at this point. Now here this is the circle. Let's say complete is the circle centered at origin of radius 1. Now here at each and every point here x square plus y square equal to 1. Now but I want to find the value of y at general value of y. Let's say y equal to here under root 1 minus x square plus minus under root 1 minus x square. But here we are in the positive first quadrant of xy plane. So in first quadrant both x and y are positive. That's why here I am taking y equal to under root 1 minus x square. Here in the starting x square plus y square equal to 1. So here y square equal to 1 minus x square. Therefore y equal to plus minus under root 1 minus x square. But here we are in the first quadrant. That's why here I am taking only positive. Here y equal to under root 1 minus x square. So here my strip CD start at x axis and terminate on the circumference of my circle, and the value of y on the circumference of the circle is general value. So in general value of y at any point on the circumference of the circle in the first quadrant, y equal to under root 1 minus x square. So here this is the value of y. Now and this strip I want to cover this region from OB to this. I want to cover this. So here I will move this strip to cover the whole region from this point to this point. So here along the x-axis, my strip move from 0, 0 to 1, 0. So here at 0, 0 x coordinate is 0 and 1, at 1, 0 x coordinate is 1. So here limits of x are 0 to 1 and limits of y, height along the y-axis. Height along the y-axis start from x-axis. Here y equal to 0 to terminate on the circumference of the circle, and the value of y and at the circumference of the circle equal to y equal to under root 1 minus x square. So here first of all I will write my first step. We have to write the region of my integration. Here first I will write the answer in the answer. So this is here I am starting the answer. The region of my integration. The region of integration is, so here first quadrant of the circle, so here is first quadrant of circle x square plus y square equal to 1. First quadrant of the circle centered at origin of radius 1 in xy plane. So in x y plane. So this is the region of my integration OAB, first quadrant of the circle. Now second thing, we have to here either you can use vertical strip method or horizontal strip method to cover vertical strip or horizontal strip to cover the whole region of your integration. Now here draw a vertical strip, let's say CD, which is parallel to y axis. Here I am drawing my vertical strip CD which is parallel to y axis. Start from x axis, and terminate on the circumference of the circle in first quadrant. Terminate on circle, here terminate on circle x square plus y square equal to 1, or you can say terminate on this circumference of the circle. So here I am writing terminate on the circle in first quadrant. In first quadrant. Now I want to write the limits of x and limits of y. So here, now tell me, I want to cover this region. I want to cover this region OAB in the first quadrant of my xy plane of the circle centered at origin of radius 1. Now here x limit, my strip move from 0 origin to a point. So here 0, 0 to 1, 0. So value of x varies from 0 to 1. So here limits of x and limits of y. Now here limits of x, here the height along the x axis. So here 0 to 1. So here x equal to 0 to x equal to 1, and limits of y. So here my vertical strip start at x axis, and on x axis value of y equal to 0. So here on x axis value of y equal to 0 and terminate on the circumference of the circle. So I want to find the general value of y for this all the point along the circumference of the circle. So here x square plus y square equal to 1, I want to find the value of y at each and every point, because the height of my strip CD vary at each and every point. So here height of my strip at this point is different, at this point is different, at this point is different, at this point is different. So here value of y is changing. So for that purpose I want to find the general value of y so that it satisfies for all the points of along the circumference of this circle x square plus y square equal to 1. So here strip CD start on x axis. On x axis the value of y equal to 0 and terminate on this circumference, and the general value of y on this circumference equal to y equal to under root plus minus 1 minus x square. But we are in the first quadrant. In the first quadrant both x and y are positive. That's why here I am taking y equal to under root 1 minus x square with positive quantity. So here y equal to under root 1 minus x square. These are the limits of x and these are the limits of y. Now I want to find this integral. Therefore the integration equal to, so double integration. So here therefore integral which is equal to, so here double integration x y by under root 1 minus y square. So here I am using the vertical strip which is parallel to y axis. So here first I will integrate with respect to dy and then dx. Here I am using the vertical strip method which is parallel to y axis. So here first I will integrate with respect to y and then dx. If you are integrating first with respect to y, put the limits of y first. So here y equal to 0 to y equal to under root here 1 minus x square, and after that I am integrating with respect to x. So put the limit of x. So here x equal to 0 to x equal to 1. So here inner limits y equal to 0 to y equal to under root 1 minus x square, and outer limit x equal to 0 to 1 x y by under root 1 minus y square dy dx. Just observe one thing. So here vertical strip method, first integrate with respect to y. Here I am integrating first with respect to y. That's why the inner limit in terms of x variable. So here now here I want to just adjust this here, which is equal to, so you know one formula. So here if f of y to the power n into f dash of y, so here dy. So here f of y to the power n into f dash of y dy, which is equal to, so here the formula f to the power n plus 1 of y divided by n plus 1. So here this is the formula. I want to use this formula. I want to adjust the term in this way. Now here, so here this is equal to 0 to 1. Now here limits 0 y equal to 0 to under root 1 minus, so here under root 1 minus x square. Now here this is the value of x. Now here I am writing, so this is my y. Here I will write this 1 by under root 1 minus y square as 1 minus y square to the power minus 1 by 2. So here I am writing 1 minus y square to the power 1 by 2. Here I will take this term in numerator. So here x. So here I will write this x. So here first I want to integrate with respect to y and then x. So here I want to integrate with respect to y. So here I will take this x at this point here with respect to this. So here this is the x as constant. I will take x outside this integration. Now here 1 minus y square to the power minus 1 by 2. Here I will write this y. Now here I want to adjust this thing in terms of this. Now here 1 minus y square to the power minus 1 by 2. Let's say n is minus 1 by 2 and the derivative of 1 minus y square is minus 2y. So here derivative of 1 minus y square is minus 2y here, but I have only y. So here I want to adjust. So here f of y to the power n. So here this is my f of y to the power n. 1 minus y square to the power minus 1 by 2 into f dash of y. So if this is my f of y, so here f dash of y is minus 2y, but here only y, I have only y. So here I will multiply minus sign and here I will multiply 2 times minus, 1 times in numerator and 1 times in denominator. So you can write here minus 2 times, no issue. So here I want 2y, so I don't have 2, so here I will multiply in the numerator 2 and in the denominator 2. So here minus 2 gets cancelled, so only y, no effect. So here which is equal to here dy and then dx. Now here in the next step I will use this formula. Now here this is my minus 2, so here I will take this and here minus 2y I will use this with the help of this formula. So here which is equal to here minus 1 by 2 times 0 to 1. So here this is x, here 0 to under root here. Here just observe on the f of y to the power n into f dash of y. So here this is my f dash of y, here minus 2y. So this is my f dash of y. So here I will use f of y to the power n plus 1 by n. So here that is 1 minus y square to the power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. So here this is my f of y, this is my f dash of y. This numerator is my f dash of y. So here I will take denominator outside, that is constant 0 to 1. So here with respect to this limit f of y to the power n plus 1 by n plus 1. So here 1 minus y square to the power n plus 1, that is n is minus 1 by 2, minus 1 by 2 plus 1 by minus 1 by 2 plus 1. So here limits. Now here I want to put the limits of x. So here 0 to under root 1 minus x square, and here at last I want to integrate with respect to dx. So here this is my integration with respect to, here I will draw one line. So here now I want to put upper limit minus lower limit. So here this is the formula. Now here I will write the same. Now here upper limit minus lower limit. So which is equal to, so here I will saw here minus 1 by 2, which is equal to minus 1 by 2 times. So here minus 1 by 2 plus 1. This is here 0 to 1, 2 times x, and here 1 minus, so here upper limit 1 minus y square. So upper limit 1 minus y square to the power 1 by 2. So here 0 to under root 1 minus x square. This is with respect to dx. So here 2 gets cancelled. This is minus 0 to 1 x. So here upper limit minus lower limit. So here 1 minus, so here the value of y. So here under root 1 minus x square to the power 1 by 2 minus, so here 1 minus 0 square to the power 1 by 2. This is with respect to dx. So here which is equal to minus here 0 to 1. So here this is x. Here square root gets cancelled. 1 minus, so here this is 1 minus x square. Here 1 minus x square, this whole to the power 1 by 2 minus 1 minus 0 1 to the power 1 by 2 becomes 1. This is dx, which is equal to minus 0 to 1. So here this is x. So here 1 minus, just multiply 1 minus 1 minus minus plus x square to the power. So here I will write this is 1 by 2 minus 1. this is dx. So here which is equal to minus 0 to 1. So here x 1 minus 1 0. So here this is x square to the power 1 by 2 minus 1. This is dx, which is equal to minus 0 to 1. So here this is here x, here square and square root gets cancelled. This is simply x minus 1. This is dx, which is equal to minus here 0 to 1. So here multiply this x square minus x. This is dx. Now here this is minus sign. So here integration of x square, x to the power here, this is x to the power 3 by 3 minus x square by 2. This is 0 to 1. So here which is equal to minus in bracket here 1 by upper limit minus lower limit 1 by 3 minus 1 by 2. So here minus here 0 minus 0, which is equal to minus 1 by 2 times, sorry, this is which is equal to minus times here minus 1 by here, sorry, 1 by 3 minus 1 by 2. So here this is 2 minus 3 divided by 6, which is equal to minus here minus 1 by 6, which is equal to 1 by 6. So here minus becomes plus. So here this is the answer. So in this way you can solve. Here I am solving this question with the help of vertical strip method. Here I am using the vertical strip method. That's why first integrate with respect to dy and then dx. So here you are integrating first with respect to dy. Write the limits of y 0 to under root 1 minus x square. After write the limits of x equal to 0 to 1. So here use this formula. Here I am just rearranging the things to convert f of y to the power n into f dash of y dy. So here f of y to the power n plus 1 by n plus 1, limits 0 to this. So here we can solve this. You will get the answer 1 by 6. This means this 1 by 6 indicates the total effect of your function over the first quadrant of your xy plane of the circle x square plus y square equal to 1. So answer is 1 by 6. So with this, thank you.